Hello, my dear champs. Welcome back to our momentum journey. Now, see, as I said, we'll discuss applications on momentum. See, first application on momentum is like this. Okay? If a body hits the wall and comes to it, then what is a change in momentum? Then, change in momentum. Change in momentum. अगर एक बॉडी है वो जब एक वॉल को लग रही है, then उसके बाद उसके अंदर का मोमेंटम कैसे चेंज हो रहा है? What is change in momentum? See, we know one thing. Let us take one wall here. If I take one wall here, now here one body, it is moving in this direction. Okay, it is moving in this direction. So it has mass m and move the velocity v. And after hitting here, it is coming to rest. Then they are asking what is change in the momentum. I know one thing, if you focus here, here my initial momentum, matlab ki initial momentum is equals to mass into velocity. Velocity is in I cap. Say, now what is my final momentum? Final momentum is mass into velocity is coming as 0. Then final momentum is 0. Now, if you ask me, sir, what is my change in momentum? Which is equals to, change in momentum is equals to final momentum minus initial ka momentum hai. Now here my final momentum is 0 minus of my initial momentum is m into v I cap, which means that my change in momentum is m into v ka I cap. Okay, it is my change in momentum and my body hit the wall and comes to rest. Write down fast. Okay, see the next case. Here, अगर आप इसे observe करते हैं सीधा से, then इधर है, if a body rebounds with the same velocity v, which means what, a body is going, hitting and it is rebounding with the velocity v only. So, which means what? See, you have one wall like this. Now, there is one body here, which is going in this direction. This body has mass and velocity in this direction. After hitting here, this body turns a U-turn, angle of 180 degree as they have mentioned. Then it is coming this direction. Then इसका जो mass है m है, इसकी जो velocity है this direction. Okay, which means it is coming like this. Now what is the change in the momentum? See, from here we know our initial momentum is equals to mass into velocity. This velocity is in I cap. Now my final momentum is equals to mass into velocity. My velocity is in the minus I cap direction coming. Now if I want to know what is my change in velocity, then I know one thing. Well, change in momentum. Final momentum minus k initial momentum. My final momentum is mv into minus I cap. Minus of initial is mv into I cap. Which means what? I'm adding this both, I get 2 times of mv, which is in I cap. This is my change in momentum. And remember one thing, all this change in momentum coming normal to the wall. This change in momentum is normal, perpendicular to the wall. So it is my change in momentum and the ball goes, hit and rebounds. Okay, take down first this also. Okay, students, see this case. If the body hits a rigid wall, normally the velocity v1 and rebounds the velocity v2, then change in momentum. See, try to understand this question. It is same as previous one. There is one wall. Here one body is hitting this wall normally, and this body has mass m1 and velocity of this body they are given v1. After hitting the wall, it is turning back and has a mass same, but its velocity turns to v of 2. Then they are asking what is the change in momentum. See, very simple. Here also same thing. What is my initial momentum? Which is mass into velocity I, which is in I cap side. Now, what is my final momentum? See, final momentum is into mass into velocity 2, which is in minus I cap. Now, if I ask you what is my change in momentum, you will say कि sir, final momentum minus initial momentum है. Final momentum जो कि minus I cap है, minus m into v1 into I cap hai. So from this I get like this minus m into v2 plus v1 into I cap sir. It is our rate of change of momentum sir. Now if you ask in magnitude of rate of change of momentum sir, then I will say like this sir. आ गया sir. So it is my rate of change of momentum when we have v1 velocity bounces with the v2 velocity. Write down very fast. You are the best because you are my students. Okay, my dear bacha pati, see this question. A body of mass m moving with the speed v hits a rigid wall at an angle theta. At an angle theta incidenting this one rebounds with the same speed. See what they are saying now. They are saying very simple. Okay, you have one wall. Okay, now here is one normal line here to the wall. For this normal line, एक ball आकर ऐसे टकरा रही है. Okay, this ball hitting it like this at an angle theta. Okay, ऐसा hit करने के बाद it is rebounding with the angle theta only. इसका जो mass m है, इसकी velocity क्या है? v1 है. इसका भी mass m है, इसकी velocity क्या है? It is v2. We know one thing. See, थोड़ी तो वेक्टर की नॉलेज है. So जब velocity a segment में जा रही है, when velocity of my body is moving in this direction, then I know with the clear cut क्या I know okay, this is if it is angle theta, this is also my angle theta ही होगा. हमको इतना तो पता है basic thing. So I won't break this with respect to here and here. I'll break this with respect to here and here. Why बोले तो because it is moving but positive ना. So हमें क्या आना चाहिए? हमें x-axis तो positive का आना चाहिए ना. So if I break here ना, मेरा x-axis negative में आ जाएगा. So if I break here, my x-axis will come in positive. So here I have mass into velocity 1. Okay. So if I break this one ना, let's say same velocity same दिख रहा है. Okay, one निकाल दीजिए. Then here I will get k mv cos theta, and here downside I will get like mv sin theta बोल को आएगा. सही. Now first part over. Now see second one, it is rebounding. When it is rebounding, I need to break this because rebounds हो रहा है ना, तो रिवर्स आ रहा है तो इसकी नेगेटिव साइड क्या होगी? माइनस साइड की साइड होगी. सी इसकी वेलोसिटी नेगेटिव साइड होगी ना. So we will break in this one. So if I break in this, then here I will get k mv cos theta, and bottom I will get k mv sin theta. Now एक तो चीज है, this both are in mv centrally, will solve individually. So from this, what is my initial momentum? So initial momentum क्या है? So mv cos theta का I cap minus mv sin theta का j cap. So हमारा फाइनल मोमेंटम क्या हो गया? फाइनल मोमेंटम इज mv cos theta का माइनस I cap माइनस mv sin theta का j cap. सर इधर माइनस कैसे आया? बिकॉज ये डाउन साइड है, I minus j होगा. I wrote here. Okay, fine. Sir, from this, if you ask me what is change in momentum, I'll write like this: final momentum minus initial momentum है sir. So final momentum में we know one thing sir, this both are is in positive में आती. See, अगर हम ऐसे करें, ये दोनों cancel हो जाती, then will be remain with this two only. Then I can write finally like this minus 2 times of mv cos theta. This is my change in momentum when they are like this. See, very simple graph. What happens now? If I make this subtraction, अगर ये लिखकर इसको माइनस किया ना, then ये दोनों तो कैंसिल हो जाएंगे. Then बचा ये और ये, इसमें नेगेटिव साइन आ जाएगा. Then we add both this. So when the body hits and returns now, then change in momentum is 2 times of mv cos theta. Okay, write down fast. Okay, see this case. This is exactly same as previous only. Just a small thing. If you focus here, they are saying कि angle theta जो है ना, ये wall के साथ बना रहा है. मतलब कि last term we took angle theta here. Now we need to take angle theta here and here. I know if I take angle theta here, then this will be our angle theta होगा. Then it will be our mv बोले तो, then here I will get mv cos theta, and this side I will get mv sin theta. Now here also same. I will get mv cos theta this side, and I will get mv sin theta this side. So my momentum, this both will cancel and only remains is this one. So अगर एक एंगल थीटा है वो वॉल के साथ एंगल बना रहेगा, then my change in momentum will be 2mv sin theta. See, very simple है. जब वो ये नॉर्मल के साथ एंगल बना रहा है, then it is 2mv cos theta. Now वो वॉल के साथ बना रहा है, so 2mv sin theta. Okay, write on this also. अबे सेपरेट से लिखो. देख भाई, सेपरेट से लिख, एक में मत लिख, सेपरेट से लिख. Okay, see, change in momentum में है, projectile नहीं है, change in momentum ही है, but we are going to discuss what is the change in momentum in projectile. Then it will be very clearly we understand. See, अगर एक projectile है, हमको पता है if I throw this with the velocity v, angle theta, I know one thing, it will travel all over the distance like this. So ये क्या होगी, ये इसकी maximum height होगी. Now if you ask me here ना, इसमें क्या होगा, we know v cos theta this side in I cap, and this side will be having k v sin theta in the j cap. Now if you ask, if I from here, let's say from point of projection to h max, इसके बीच में what is change of momentum if you ask me? See, we know one thing, here we know one thing, our momentum initial value is mv cos theta I cap plus mv sin theta j cap. सही है. Now they are saying that it is at maximum height at this point. We know one thing, at this point this side velocity will be 0 and this side I will be having velocity mv cos theta ka I cap only. So here I can write mv cos theta ka I cap only. Now I know one thing, they are saying rate of change of momentum, which means rate of change of momentum which is equals to p final minus p initial. Now if I subtract this one, then I will get mv cos theta I cap minus mv cos theta I cap plus mv sin theta ka j cap. From this both cancel, then I will be remain with mv sin theta ka j cap. So my change in momentum from the body travel from a point of projection to maximum height is this one. Kindly take one first. Alright, fine. So I hope you have done this one. Now there is one more case in this only. Let's take our B from a point of projection. I write like this: point of projection to max range. Max range. See, POB means point of projection, no? Which means this point to this point till this point. What is my change of rate in momentum? We know one thing, again I know my P initial is equals to mv sin theta ka j cap plus mv cos theta ka I cap. Now when I get to final velocity, here final velocity, this side it will be mv cos theta ka I only, but downside here mv sin theta ka j cap. So I can write from here mv sin theta ka minus j cap plus mv cos theta ka I cap. Okay. Now, agar if I write rate of change of momentum, which is equals to final momentum minus k initial momentum होगा. So अगर हमें उसके फॉर्म में इसे अप्लाई करें, then I will get like this k mv sin theta minus j cap plus mv cos theta I cap. Now this term I need to subtract, then minus mv sin theta का j cap minus into plus क्या होगा, minus mv cos theta का I cap. Now I know one thing, both are same, so I can cancel this one and remain with this one. Minus hai, then my rate of change of momentum will be minus 2 times of mv sin theta into j cap. This is my rate of change of momentum when the body hit from here to here. Okay, so projectile में भी हमें rate of change of momentum पता चल गया. When the body travel from point of projection to maximum height, and when the body travel from point of projection to end point, A और B. A में मैक्सिमम हाइट तक गया, बी में मैक्सिमम रेंज तक गया. लिख लीजिए जल्दी से. Okay, my dear chums, see, one last case we'll discuss and end this because all majority of the change in momentum is over. Now only one symbol. Okay, when you have an object, it's rotated to angle theta. Okay, from here it will angle theta. Then what is the rate of change of momentum? See, this question we have angle theta. Then you know how to solve. Now initially we have initial momentum which is equals to m into v, mass and velocity same, and our final momentum is also m into v, mass and velocity is final, because mass and velocity is same. Here speed is not changing, only angle is changing. So if I ask you what is my change in momentum, then what you will say, sir, it is square root of p initial. See, both are equal to, so let us say as p only. Both are equal to p square plus p square minus 2 times of p and cos theta. Here I can write as like this, okay? 2 times of p square minus 2 times of p square into cos theta. Now I can write it as 2 times of p square into 1 minus cos theta. Now I know one thing, okay? This cos theta is equals to 2 times of sin square theta by 2. I know this one. On multiplying, I will get like this, okay? 4 times of p square sin square theta by 2. Now final expression, rate of change of momentum is equals to 2 times of p sin theta by 2. It is my change in momentum when my particle is rotated to angle theta. Hope you got it. All the illustrations, all the examples are very great. You practice one time, read one time, and did you like the video? Yes or no? Like it? Okay. Like it? It's swear on your seat. Alright, fine. So, you have watched till now, till that. So, thank you so much. We'll meet you in next topic, next video with our second law and examples, or else we'll do some advanced illustration. Till the Tata, bye bye, Shabba care, bye, Allah Hafiz. Take care, my dear champs.